And next we have overview of current technologies for food authenticity testing, case studies and challenges of regulator control by Dr. Niladri Chatterjee, CIFT. So before inviting Dr. Chatterjee on screen, I would like to tell about them. Dr. Niladri Chatterjee is a scientist at ICAR-Central Institute of Fisheries Technology, Cochin. His research interest includes advanced mass spectrometry techniques, analytical method development for environmental contaminants, Foodomics and Chemometrics. During his postdoctoral stint in Queens University Belfast, he worked on ambient mass spectrometry for real-time detection of seafood fraud. Dr. Chatterjee was the recipient of SERB Early Career Research Award and AOAC India Young Scientist Award. So now we welcome Dr. Niladri Chatterjee, scientist, Central Institute of Fisheries Technology, on screen.
Thank you for the introduction. Good afternoon, everybody. So I am supposed to speak on the overview of the technologies which is available for food authenticity testing. So I organized my presentation in two parts. I am audible, right? So I organized my presentation in two parts. The first portion was a bit of introductory, and then it goes more technical. But I'm speaking after Dr. Banerjee, Dr. Poppings, Dr. Dawn, so they made my life difficult. Many of the initial slides may be identical to them. But yeah, maybe it can be a good revision for the audience. Sometime KJL may decide to have a quiz for them. So it's a good revision for you, but I'll quickly skip those slides. So can I have the first slide, please? So here, please remember that there are 8 types of fraud, as Dr. Banerjee told. It's a revision for you, but 8 is not a definitive number. The fraudsters are very dynamic, if I may say. There can be a new type of fraud in the future. We never know. Sometimes we feel that there is a equally high-end and sophisticated lab running on the opposite side of the fraudsters also. As in the scientific community. May I have the next slide, please? So at least let me elaborate how huge the impact of food adulteration is in our sector, which I represent, that is food of animal origin, meat and seafood products. We all know that the 2013 horse meat scandal in EU, where horse meat was substituted in beef, probably that was the trigger event when authorities and researchers in most of the EU countries took note of this serious problem. Professor Chris Elliott from Queens University of Belfast led the UK review on this horse meat scandal and uncovered the extent of the fraudulent network, and famously this report is known as Iliad's report. So, however, despite all the vigilance and scientific efforts from the scientific community, in 2018 alone, France was affected by horse meat fraud at least 4 times, and Germany faced similar problems in 2019. So, in China also, we have news of rotten meat scandal, and in our own backyard in Calcutta, we had this huge scandal where 20,000 kgs of carcass meat was seized. Probably for India, this is just the tip of the iceberg in our sector. May I have the next slide, please? In fisheries sector, the problem is equally big. Here, Oceania, there is a ocean advocacy NGO. So they reports that 84% of the white tuna sold in USA is actually escolar. So escolar causes severe food poisoning. So this type of food fraud is a public safety concern. Not only it is an economic concern, this is a public safety concern. Again, it reports that 59% of the tuna sold in the US restaurants are not actually tuna. So there are also reports of mislabeling of farmed Atlantic salmon as wild caught salmon to fetch a premium price. And in India, again, there is a issue time and again flagged by the regulatory agencies that farmed shrimp is being passed on as a wild caught shrimp. so as to avoid the mandatory antibiotic testing and also to fetch better prices. So may I have the next slide, please? So here again, like this is a revision of Dr. Banerjee's slide, but the take-home message from here, what I mean to say is that yes, EU has a big database, European Union has a big database, and the China along with EU has a big database, but in India we don't have a database yet to be. We are such a big economy, and it is like really a point of concern that we don't make a database of our own. Can I have the next slide, please? So here again, I'm trying to make the case for my sector of fish and fisheries product and the meat and meat products. So this database are a bit tricky. If you see the commodity wise, the milk, olive oil and honey are the most vulnerable commodities taken for food fraud detection and all. But may I have the next slide, please? But when you check it ingredient wise, seafood and meat product goes up, olive oil, honey and all goes down. So this is an equally big problem in seafood sector and meat product sector, which need to be taken care of. May I have the next slide, please? Next slide, please. So here again, I'd like to show some data from the EU Food Fraud Network and the Administrative Assistant and Cooperative System. So here also, if you check out the data again, you will see that seafood is one of the most vulnerable commodity. It comes in the top 3 food categories, and more requests from member countries came for these commodities. So may I have the next slide, please? So all these databases, as Don was mentioning, and showed quite a few reports from India. So all these databases records food fraud cases from India. And this European Union Food Fraud Network reports that there is 9 cases from India, which is just next to maybe China, which is quite worrisome for the reputation of the food supply chain. And the readiness of our regulatory system. So may I have the next slide, please? So here onwards, it goes a bit of technical. In this slide, I'm trying to show you a summary of all so here in this slide, I'm trying to show you all the different technologies, summary of different technologies available for food fraud detection. So there is vibrational spectroscopy, there is NMR, there is mass spectrometer, and there is others. For others, what I mean that different DNA-based techniques and also isotope ratio and ICP-MS-based technique. So here I'm going to touch over the different chemical techniques and not going to touch over the molecular techniques because there will be expert speaker after me. Indranil will be speaking after me. So I don't dare to touch those molecular methods. But if you see in this slide, there is a natural progression over the years. As you see, during 2003 to 2007, vibrational spectroscopy was the most commonly used spectroscopy, most commonly used detection technique for food fraud. But afterwards, 2008 onwards, you can see a change more towards mass spectrometry and NMR-based techniques. So the good thing about THERMO is that they have product portfolio for all different techniques, except I think maybe they don't have NMR yet, but they have product portfolio for all different techniques. And as my presentation progress, you will find that no single technology is enough to detect food fraud. So may I have the next slide, please? So let us start with vibrational spectroscopy. So vibrational spectroscopy, I mean that FTIR, NIR, and Raman. So here in our lab, we did a small experiment with FTIR spectroscopy. So here we have recorded spectra of different shrimp species. So here basically the spectra looks like this after different filtration and derivatization treatment. So to a chemist, this looks like a spectra where they get chemical information, but to a bioinformatics or a statistician, these are data points. So this FTIR spectra can be exported as data points, and with that data points, you can do a lot of machine learning and chemometrics modeling. So what we did with this FTIR data, we developed a couple of models. Can I have the next slide? So here we developed a model to authenticate shrimp species, three major commercially important shrimp species, that is king prawn, that is the Vanamai white-legged shrimp, which is most commonly aquacultured in most of the countries, and second is the black tiger prawn, which is comparatively expensive, and often king prawn is like passed on as a black tiger prawn. And another premium shrimp from South America, that is Argentine red shrimp. So in this model, in this predictive model, we could get a prediction capability as good as 86%. So you can see a clear clustering of these three types of shrimp. So can I have the next slide, please? So again, the challenge was to authenticate the geographical origin of king prawn, because some countries they employ slave labor in their aquaculture, and as a consumer, definitely you will not like to have shrimp coming from that aquaculture. So it is always important to know the geographical origin, and also in European Union it is a mandatory requirement to mention the geographical origin. So here again, the FTIR spectra, it looks like after different filtering and data treatment, it looks like that, and it was converted into a data point. And here too, again, we developed a predictive model. Can I have the next slide? So here in the PCA model itself, you can see that there is clear variation in the data between the India origin, Thailand origin, and Vietnam origin shrimps. So PCA is a unsupervised statistical analysis, statistical multivariate analysis, but still without any supervised data points, it shows a clear variation in the data. Can I have the next slide? So when we made a further model using that PCA plot, we developed a OPLSDA model which could clearly discriminate between these three geographical origins. Now, this is my experiment done in my lab. So there are different application on different product commodities. So I don't want to show them and lengthen this presentation as because they are not my own work, but just I like to show you some important research work done using vibrational spectroscopy, like this one, like authentication of extra virgin olive oils, and then again adulteration detection in oregano, and also adulteration detection in garlic, and also the one in the using a handheld near infrared instrument. So may I have the next slide, please? So here I like to show you one case study from my postdoctoral lab. So they that time our group were working on oregano. So oregano fraud is like a big thing, right? At that time, like oregano leaves were adulterated with citrus leaf, myrtle leaves, and olive leaves at different percentage level. So our laboratory did a survey study, and they observed high level of adulteration in oregano. So afterwards, like in India also, you can see like there were reports of spice adulteration and all. 8% of the world spices supply come from India. So this is quite worrisome that in from India also, especially in black pepper, there were reports for adulteration. Similarly, there were reports for olive oil adulteration as well. May I have the next slide, please? So here, what I want to show you that how FTIR spectroscopy can differentiate and detect the adulteration in Oregon. So here, if you see the inset, that here you can see that gradually with the increasing adulteration, create predictive models with such spectroscopy data, you get wonderful prediction capability, wonderful prediction models. May I have the next slide? So these are the models which clearly could differentiate between adulterated and unadulterated oregano, or unadulterated with different bulking leaves like hazelnut, sumac, olive, maple, etc. Spectrometry based approach. So can I have the next slide, please? So from this research, two publication came from my postdoc lab, Queens University. That first one was developing a comprehensive approach in which they did DNA-based authentication followed by rapid testing with FTIR and followed by authentication using mass spectrometry. A paper has come which shows that vibrational spectroscopy methods can be as accurate as up to 90% or more than that. So the good thing about vibrational spectroscopy is that there are miniature spectrometers available in market now, and these miniature spectrometers can be taken to the field and you can record the data immediately and you can get the result there itself. So it is a non-destructive analysis, so quite attractive that way. And in the point of harvest, you can analyze your produce and get a result then and there. So that way it makes a very attractive technology for food fraud detection. May I have the next slide, please? But there are challenges in vibrational spectroscopy methods. First of all, I must say that these are, despite all the success, say up to 90% accuracy and all, these are rapid screening methods. They still need a confirmation, a confirmatory test in the laboratory. But the good thing about this technique is that they reduce the number of sample which is coming in to the laboratory for food fraud testing, because only the suspect sample can come in and other samples we can simply screen through vibrational spectroscopy. But again, this vibrational spectroscopy needs careful model building. So you need to train your models, and that involves recording thousands of spectra, and after that you have to very carefully make a predictive model, and we have to be careful not to overfeed the model. So this is a laborious process, time consuming process, but yes, again, when the models are built, it can be deployed in field. It is fast, non-destructive, and saves a lot of time. So that is the advantage of vibrational spectroscopy techniques. Can you have the next slide, please? So after vibrational spectroscopy, NMR. So again, it will be very brief because as of now, I have not worked on NMR for food authentication. I didn't get the pleasure to work on NMR for food authentication, but as you know that NMR has often been used as a confirmatory technique for food adulteration detection for wine, fruit juices, and honey. So if you see the Bruker instrument for food authentication, they have database of wine, fruit juice, honey. Typically, this type of detection requires very large databases. For example, uh, the wine database contains more than 20,000 spectra. And there was recently a report of honey authentication using NMR. So again, here I'd like to say that this is again, these methods are very robust, but again, depends on the size of the database and all. So the database is still growing, and again, like in future, this will be a very, very robust method for honey and fruit juice authentication as well. So here also basically the principle is basically same. In vibrational spectroscopy, you get a spectra. In NMR also, you get a NMR, H1 NMR spectra, and you from that spectra you can extract the data points, and from that you can build lot of machine learning algorithms to predict the authentic or authenticness or adulteration in your sample. So this was NMR in brief. Can I have the next slide, please? So another interesting technique is the elemental analyzer and isotopic ratio mass spectrometer. It has been often a preferred method for identifying adulteration with foreign sugar in honey, grape mast, and fruit juices. This is also the preferred technique to detect the geographical origin of different commodities. Right. So here I like to draw your attention towards this recent publication, which uses gas chromatography combustion isotope ratio mass spectrometry. So here they did compound specific isotope ratio and observed that when they check the isotope ratio in proline, they get a better prediction of adulteration of grape mast as compared to elemental analyzer based IRMS spectrometry. So the take-home message is that in future this technology will evolve and focus will be more and more on compound-specific isotope ratio determination. It is a really interesting technique and may have wonderful application in fisheries sector. We'll love to work on this technique in future if we get a chance. So next slide, please. So the next workflow, the typical workflow, mass spectrometry based workflow. So here again, it involves some extraction and then chromatography separation and followed by high resolution mass spectrometry. So here again, you can identify the ions and with those ions, you can do a lot of statistical analysis to identify the biomarkers. And using those biomarkers, you can make a targeted method in LC-MSMS. So the problem with LC-HRMS based authentication method is that mass spectrometry is not as repeatable as spectroscopy method like NMR or FTIR or say NIR or Raman. So here this makes identification of biomarkers very crucial to make this method suitable for regulatory application. So here when the number of target ions are reduced and you go into MRM based targeted detection, then this method becomes very repeatable and can wonderfully work as a regulatory method. So can I have the next slide? So here again, I like to show one of my study. So here we tried to authenticate shrimp species. We chose 5 economically important shrimp species: black tiger prawn, the white leg shrimp, that is the king prawn, the Indian pink shrimp, Indian white shrimp, and also the Argentine red shrimp. So again, can I have the next slide? So we acquired the data in a LC high resolution mass spectrometer, and using the fingerprint data, using all the ions, we developed models. And as you can see here that the models could clearly predict the difference between different type of shrimp species very easily. But again, as I told, that identification of marker is very important, because you cannot employ this LC-HRMS based method for regulatory control probably, because there will be variation in the mass accuracy and there will be slight fluctuation in the masses of that particular ions and all. So it is very important to identify the biomarkers to have a regulatory method. May I have the next slide, please? So again, the same data was explored to predict the geographical origin of the shrimp. So here again, using the same data, we could predict the geographical origin of the shrimp. The first model is for the tiger prawn, and the second model is for the king prawns. So in tiger prawn, we could clearly identify the shrimp tiger prawns originating from India, Madagascar, Sri Lanka, and Vietnam. And similarly, in case of king prawn, also we could differentiate the geographical origin. So this is the beauty of metabolomics data. The same data can be explored for different biological questions. First, we explored the data for authentication of species, and afterwards, the same data we explored for authentication of geographical origin. Can I have the next slide? As I told that identification of the biomarkers are very important. So using our data processing, we could come out with this many markers for different shrimp species, which were characteristics for that species, and we developed a MRM-based LC-MS method for those markers. So using these markers, we developed predictive model, and which could clearly authenticate species origin, and as well as we got very interesting observation in geographical origin. Can I have the next slide, please? So here in geographical origin, we could see that the levels of this, the relative abundance of these markers were varying based on their location. So the first market like India, Madagascar, Vietnam, Thailand, based on their geographical origin, they had different relative abundance. So these markers has potential to be used for building predictive models, which can be used for geographical origin application as well. Can I have the next slide, please? So here again, you can see how the markers were detected and their relative abundance. Again, we thought of exploring the data to differentiate between wild-caught and farmed shrimp, because initially in my presentation, I was telling that this is a very big issue that farmed shrimp is being mislabeled as wild-caught shrimp. So here we could identify 14 phospholipid biomarkers, which could differentiate wild-caught and farmed shrimp across species. Wild-caught group had different species and farmed had different species. May I have the next slide? So here, this for identifying these biomarkers, we used MSMS. We could identify some of the fragment ions, and also the mass error was less than 2 ppm in this case. So using only this 14 phospholipid biomarkers, we built a model. Can I have the next slide, please? So here you can see these 14 biomarkers could clearly differentiate between wild-caught shrimp and farmed shrimp. So even this method has potential to be used in regulatory control, because only markers, a limited number of markers are there, and you can easily transfer into a targeted method and can be used for even regulatory control as well. Can I have the next slide, please? So the another type of mass spectrometry technique will be the ambient mass spectrometry technique, where you don't have a front end LC. The ions generated from the product directly goes into the mass spectrometer. Reams will be an example. Other than reams, there are different type of ambient spectroscopy mass spectrometry technique like ASA. Then you have paper spray mass spectrometry, etc. So can I have the next slide, please? So here again, we did an experiment where we tried to authenticate the species and geographical origin in the same predictive model. Here, the advantage of ambient mass spectrometry techniques are that you can get the result instantaneously, and you don't have to wait for chromatography separation or data acquisition, and it doesn't involve any sample preparation at all. So here, as you can see in this predictive model, we can clearly differentiate different shrimp species as well as deep prawn species originating from three different countries. So this model, again, it was acquired with almost more than 5,000 spectra, and it was validated with a set of unknown samples, and which could clearly authenticate those samples almost with 97% accuracy. So can I have the next slide, please? So a couple of publication has come, including one from me, which is in Journal of Chromatography, and others in scientific reports and all, using this type of techniques. This mass spectrometry will be like a wonderful technique to be worked on. Recently in our lab, we acquired a LC Exploris 120 orbit trap. We are pretty excited to work on this instrument for food authentication and develop similar workflows and methods for different food commodities. So can I have the next slide, please? So here again, like can I summarize? May I summarize the different techniques? So here we have vibrational spectroscopy, we have NMR, we have IRMS, and we have LCMS, LCHRMS. So different techniques are useful for different purpose. Like vibrational spectroscopy is a rapid method, can be used for screening a lot of food in the field. Again, IRMS can be a confirmatory method, especially when geographical origin is the question, where DNA-based methods doesn't help much. Then you have the mass spectrometry and NMR. Again, these chemical techniques can answer questions where DNA-based techniques doesn't help much, like differentiation between wild caught and formed of the same species, or say differentiation of the geographical origin, such things. So, but as I told before that no single technique is like enough to fight food fraud. The war on the food fraud need to be fought on many fronts. So all different techniques has its own application and own area. And I'll not go in detail in molecular techniques, but I'll just like to comment that maybe vibrational spectroscopy is a rapid screening rapid methods when it comes to chemical-based technologies, chemistry-based technologies. Similarly, maybe RT-PCR and other PCR-based techniques can be similarly as similar as vibrational spectroscopy, like rapid screening methods, and NGS can be the confirmatory method. So can I have the next slide? So yeah, next slide, please. So with this, I'll end my presentation. So thank you very much. Maybe we can have some question answer during the question answer session. Thank you.